Okay, I'd like to do a few examples from our homework that are about these horizontal and vertical shifts of parent functions and then their transformations. So let's look here. I'm going to go ahead and do numbers 1 and 4, and I will do, how about number 3 as well. Okay, so when we're looking here, the first thing they want to know is what is the parent function? And we can see here that our parent function is the quadratic. It's x, excuse me, my pen is having a problem, x squared. Our transformation here is that it is minus 3. So this is a shift 3 units down. And when we're doing these problems, I like to do them in multiple colors because I will draw the parent function on here, and then I'm going to draw the translation. So the graph we know of x squared goes through 1, 1, and let's see here, 2, 4. So it's something kind of like this. Right, that is x squared. And then if I want to show this shift of down 3 units, that means that this entire graph, which is centered here on the y-axis, is going to now have a base that comes down 1, 2, 3 units. And again, remember these are sketches, so they don't need to be perfect. And that is our translated sketch, right? This is f of x is equal to x squared minus 3. Okay, let's go ahead and look at number 4. This is a square root function, right? Here I've got my base, and here is the square root of x. And I know that the square root of x, well, at 1 it's 1, and at 0 it's 0. And if I get over to 4, it's up here at 2. It kind of looks like this. Right, that's my square root of x graph. And here it tells me, well, I've got a couple of different transformations that are happening here. I've got this 4 outside and a 2 inside. So I'm going to be shifting up 4 units. But I also have a horizontal shift here, this minus 2 that is in the operator. And remember, so this is minus, we think, oh, that means we should be going more negatively, but this actually means to go more positively. So, and 2 units to the right. So maybe I probably should not have drawn this here, because I need to now go up 4, 1, 2, 3, 4, and shift 2 units to the right. My new function is right up here where I wrote f of x. 1, 2, 3, 4, 1, 2. Right here is my new, the new corner, right? That would be the same thing as the origin here. And it kind of looks like that, right? That's my shifted graph. Again, these are sketches. They don't need to be perfect. Okay, let's do one more. Here we've got an absolute value equation. Right, we see absolute value. That's the parent function. And if you recall the absolute value function, this one's a nice easy one to draw because it's perfect diagonals coming up each side. Right, so our parent function looks like that, right? This is f of x equals the absolute value of x. And now let's go ahead and look at my transformations and see if we can figure out what it is that has happened here. Well, I've got one inside and one outside. Recall that anything outside is a shift up or down. So shift down 2 units. And I've got this horizontal left-right movement. But recall, if it's positive, that means I'm moving to the left. So in the last example, it was a negative value, I moved right. Positive tells me to move left. And 5 units left. Okay, so now I'm going to go ahead and let's move our function. We want to go 2 down and 5 left. So notice I always start with where it is based here at the origin. So go down 2, and then 1, 2, 3, 4, 5 units to the left. That is my new base of my function. And then we're just going to draw our diagonals coming up from that. So my new translated function is going to look like that. Oh, sorry, I didn't draw my lines perfectly, but that is my translated function. Good luck. Let me know if you guys have any questions. Have a good day.